All right, so back to our regular schedule program. So everyone should understand this area about naming alcohols now. All right. So we're gonna be pressing forward, and we're gonna look at some properties of alcohol. So one, look at general properties. Whenever in chemistry we ask about properties, it could either be one out of two things. It could be physical properties and chemical properties. All right. So one of the first properties we often discuss is physical properties. And what a physical property basically is, it's a property you can experience with your senses, right? That's to put it in a simple way. So something that you can measure without damaging or changing the composition of the substance that you are observing. So example, in this case, we're gonna start with a physical property, all right? So physical property may entail things like boiling point, melting point, all right? It could entail things like color and these things where the substance doesn't change, all right? Okay, so let's look at the first one. We say that alcohol molecules are polar. So where physical properties entail, it covers one of these areas in a mass way, all right? So what we're looking at here is polar. Due to the presence of the polar OH group, the volatility of alcohols and the solubility and their solubility in water are both related to their polar nature or the polar nature of their molecules. So if we, right, very good, excellent, because that's what I'm going to talk back. We did touch on it sometime before, but I know that we often have to kind of repeat again what polar actually mean. Anytime you think about polar, you think about poles, just as the Earth have a North Pole and a South Pole, or as well as we can look at a magnet having a South Pole and a North Pole as well. In this case, we are looking at charges.
Right.
So positive or negative charges.
Very good. So what happens when we have compounds? There are some compounds that are polar in nature, and there are some that are non-polar. What it means to actually be polar is to have a positive and a negative end. We're talking about a delta positive kind of charge. So one part of the molecule is going to be more positive, and another part of the molecule is going to be more negative. Right? So having that characteristics within the molecule, they interact with other substances around them physically in different ways, right? Or in the major way that we look at is basically solubility, all right? And we're gonna get to that where we have the last point here. Somebody wanted to say something? I was just checking. All right, so where this is concerned, we have being polar can affect its volatility of alcohols and the solubility, that one particular characteristic of an alcohol. Now, alcohols are less volatile than their corresponding alkanes with the same number of carbon atoms. So we know an alkane. Example, we have butane is an alkane. Butane is volatile. It exists as a gas at room temperature. Reason being because its boiling point is very low. It's lower than the temperature that a room is going to be in general. So it's going to exist as a gas in that particular temperature. So what we refer to as these substances being volatile are substances that have very low boiling points. All right. So alcohols are less volatile than their counterparts. When we're talking about the counterparts, or we're talking about the ones that have the same carbon atoms as they have. So butane is going to be more volatile than butanol. Okay, so butanol is going to have a higher boiling point than butane. However, alcohols are volatile as well because they have low boiling points. They tend to have that low boiling point, and as a result, if you take mentholated spirit or any of these alcohols and you place it on your hand, what happens to it?
It vaporizes.
It evaporates. You even have nothing to do with it, because just the simple temperature of your body is going to cause that alcohol to change phase from a liquid to a gas. All right, so it's going to just evaporate. Okay, that volatility can also has a kind of connection as well to its chemical reaction, but we ain't going to get into there as right now. So what happens here now? The boiling point of an alcohol is always much higher than of the corresponding alkane. Boiling points of alcohols increase as the number of carbon atoms in their molecules increase. So when they increase in the number of carbons, right, the physical property is going to change, just as all the other alkanes, all the other organic compounds. We would have established this at the beginning of organic chemistry, where we know that as you increase in the carbons, the physical properties of the compound going to change, even though they would have the similar characteristics of a homologous series that they are in. Their physical properties will change. Right? Next, we look at the general rule of solubility states that polar solutes dissolve in polar solvents. All right, so since alcohols are polar in nature, they will dissolve in polar solvents. However, water is being a polar solvent, therefore alcohols will dissolve in water. That's why if we go back to mixtures and separation, you remember having miscible liquids?
Yeah.
Right, and a miscible liquid is basically two liquids of differing boiling points, but they form a homogeneous mixture. All right, so in this case, water and alcohol can do that because of the polar nature of the both compounds. All right. Now, can solubility be affected as well with the number of carbons? That if it increases, yes, it can. As what we will observe is that solubility will decrease as the number of the carbon atoms in the molecules of an alcohol or any other organic compound, as they increase, the solubility also decreases. The solubility will decrease. All right. So number of carbons does affect the physical properties of the homologous series. All right. So we are moving ahead, and we're looking at the next properties, which is chemical properties, and we're looking at reactions of alcohols now. Okay, so just making a recap so far since we've been here, we know what an alcohol is. We know what categorize an alcohol is based on its OH group. All right, we know about naming alcohols and the isomers so far. It's based on the branches and the placement of the functional group, determine the name of the alcohol, and we would have covered as well the where alcohols are concerned, the physical properties so far, where we deal with volatility, talking about them being polar, and as well as the solubility. So now we're looking at reactions of alcohols. Alcohols undergo a variety of reactions due to the presence of the hydroxyl functional group. The strength of the reaction decreases as the number of carbon atoms in the alcohol molecule increases. All right. So the first reaction we have is what? What do we have? Ta-ta-da-da.
Combustion.
Yes, combustion reaction.
Combustion.
Right. So combustion, we have alcohols burning air or oxygen, producing carbon dioxide and water as steam. So we would have learned about combustion reactions before, and we would have learned that in a combustion reaction, carbon dioxide and water is our main products. Okay.
Yeah.
The reaction is exothermic, producing a large amount of heat energy. That's why anytime we have alcohol and we put a flame on it, it will have this sort of explosive effect. All right. If you have alcohol, if you put methylated spirit on your hand and you light the fire, you're gonna see that same thing. I'm not saying that you should do this, but I'm just giving giving the notice that how it would behave, because the compound is exothermic in nature. All right. So one example is the combustion of ethanol. So we see here ethanol reacts with oxygen to produce carbon dioxide and water. And this delta H here, we say is negative. And once it's negative, we know that it is exothermic. All right. And we're going to touch on these as we go on in other areas. All right. Like reactions, energetics. This is where we cover most of these areas. So here's what ethanol burns with a clear blue flame. So I took a picture to show what a clear blue flame would look like, right in the corner of your right here. So it burns in a clear blue flame. Why is that? Because the ratio of carbon to hydrogen atoms in the molecule is low. So in other words, we don't have more carbons than hydrogens, right? The ratio is low. So we have a lot more hydrogen atoms in comparison to carbon. So we have a kind of that ratio. When it burns now, it's gonna burn well. We're gonna have complete combustion. It's easier to have it, and as well as a result, we're going to have a clear blue flame. What does that mean? That means that all the carbon is converted to carbon dioxide, and no unreacted carbon remains to produce soot. So what is soot? Soot is actually basically a kind of
like black stuff.
That is correct.
It was marked in war from burning a coal as one of the ship's common. Yeah.
Excellent. So that's an example, and depending on where it is, if you look at diesel vehicles as well, if you or any vehicle that burns fuel, if you go at the exhaust where we have the products coming out from the burning of the fuel, and you place a white let's say a napkin or so, you're going to realize that you're going to collect some black stuff. All right, which is example of soot. All right, which would result in some incomplete combustion in the engine. All right, so which means that all the carbons were not converted to carbon dioxide. All right, everyone is there? Everyone is clear?
Yeah.
All right, good. So let's see what else can we get. So Toya isn't there again. Where did she go? Reaction of alcohols again. So alcohols can react with sodium. So in reacting with sodium, they produce something called sodium ethoxide and hydrogen. So this is sodium ethoxide. This is the formula for it. What happens in the reaction is basically when sodium metal goes into the reaction, it displaces a hydrogen, the hydrogen on the OH group. So where we have the OH, and if you look on the corner here, the OH is replaced by the sodium, all right? And that H is what forms the hydrogen gas. So when a piece of sodium metal is dropped into ethanol, steady effervescence occurs as hydrogen gas is evolved and a colorless solution of sodium ethoxide is in alcohol is formed. I think what I'm going to do, I'm going to send you a video with this. There's a nice video on YouTube. I'm going to send you so you could be able to see this reaction in play. All right. So example we have here, sodium. Well, we have the ethanol here reacting with the sodium, and it's going to form what we call sodium ethoxide. All right. With an alcohol solution and hydrogen gas. So far we have, oh, look at it in the corner here. It was supposed to be in the next one before. All right, so I'll send you that video afterwards. So what we have here again, we have dehydration of alcohols. So far we had combustion reaction. What happened there? Everyone's seen, right? So far we had the combustion reaction. Next we had reaction of sodium, and next we have now where you have dehydration of alcohols. So we are almost finished. When an alcohol is mixed with concentrated sulfuric acid and the mixture is heated to 170 degrees Celsius, the ethanol is dehydrated to ethene. So can I produce an ethene or an alkene? Yes, I can. Right, just taking an alcohol of whatever length chain I have, putting it in sulfuric acid, which works as a catalyst, and heating it to about 170 degrees Celsius or above. And you're going to dehydrate that ethanol and you're going to form an alkene. All right. This can be achieved in two ways. One, just as we would have said, you heat the ethanol in excess sulfuric acid at a temperature of 170 degrees Celsius, where the acid acts as a catalyst in the reaction. Or you can pass the ethanol vapor. So in other words, you heat the ethanol and you have the vapor, and you pass the vapor on heated aluminum oxide. And by doing that, it's going to also produce the same alkene as well. So here we have an example. So we have ethanol reacting with the sulfuric acid, and at the temperature here is 180 degrees Celsius to produce, you see, in ethylene, but it's same as ethene, right? Okay, so, and water. Okay. And this is the reaction that we have here. Same reaction. Okay. So this was the reaction on the side here. All right, but I am going to send you that afterwards, okay? So we can complete this reaction. So I'm going to send you that afterwards, okay? So here we have our next reaction, and this reaction we have is oxidation of alcohols. So far we have combustion reaction. What's the next reaction we had?
Reaction with sodium.
Reaction with sodium, and the last one we did here was what?
Dehydration.
And dehydration. So far those are the three reactions that we have.
Powerful.
All right. So the last one that we're looking at, well, not quite the last one, but almost the last, or the second to last one, is oxidation of alcohols. When an alcohol is heated with a powerful oxidizing agent, such as acidified potassium manganate solution or acidified potassium dichromate solution, the ethanol is oxidized to ethanoic acid. So I can use an alcohol and produce an alkanoic acid by carrying under an oxidation reaction with a strong oxidizing agent. All right. So how do we represent this reaction? This reaction is represented in this way. And those of you who would have taken a try at the multiple choice question that I posted on Socrative, would have seen a reaction having this same thing, and it might have confused you because you didn't cover this area, but today you're going to see it. So this is just a way in saying I'm using an oxidizing agent, okay? It's not potassium manganate or potassium dichromate. It could be either or, but as a result of the reaction, you're going to have ethanoic acid being produced and water. Okay, everyone is clear? Now, here is what. This on the corner, we're looking at the reaction here. This purple solution is what potassium manganate looks as, right? It has a purple color. But when we add an alcohol to it, it decolorizes the potassium manganate, all right? And making it a clearer color, all right? So it decolorize it. And now in here, we're going to expect to have, in this case, if it was ethanol and the potassium manganate, we're going to have ethanoic acid being formed, all right? On the other hand, when we are looking at the potassium dichromate, which has an orange color, the picture doesn't show it as how rich it normally looks like, but you should get the gist. It has a color change from the orange looking color to a green color, and that green color shows that is what it's an and it's evidence for us to say that the substance that we have is an alcohol. But we know what happens in the reaction. Ethanoic acid is produced, but what happens is that if I should add a little here, I know we didn't go through oxidation and reduction quite as yet, but you should note this, that the ethanol would act as a reducing agent, all right? So what happens in an oxidation reduction reaction, we have two processes, they work hand in hand. So it's one process, but two things occur. There is oxidation and there's reduction. So in this case, the potassium manganate or the potassium dichromate is an oxidizing agent. So it's a strong oxidizing agent, as we see here. The ethanol in this case is going to be a reducing agent. So when they react with each other, oxidizing and reducing agents will react with each other. They are going to affect each other. So what happened? The ethanol was oxidized. Was one way we could know this, it gained oxygen here, all right? So it was one, and now it has two. So it gained oxygen. So it was oxidized. And on the other hand, where we're not seeing here being done, where the potassium dichromate is concerned, the dichromate in the potassium dichromate is becoming reduced. And when it becomes reduced, it is moving from this high oxidation stage, which is 7, and it goes down to somewhere like a 3+. But when chromium is at a 3+ charge, it exhibits, or it shows itself as a green color. When it is at a 7 or a 6+, it has an orange color, all right? So what happens, the change, you can know that an oxidation reduction reaction occurred because of the change in the color, all right? But what we are going to leave here with is that once ethanol is in the presence of an oxidizing agent such as potassium manganate and potassium dichromate, ethanoic acid is produced. Okay? And that's what we want to make sure we leave with here. And last but not least, to close off the slide, we have reaction of reaction with an alkanoic acid. So an alcohol can react with an alkanoic acid, and that is where we're going to be touching in on esters. So we're going to be seeing that in our next class. Okay? So everyone is clear there?
Yep.
All right. So what we're gonna do, we're gonna just have a little bit of a review. I'm gonna be asking a few questions. Yes, you can go ahead. Anybody want anything clarified as well, you can ask. If you want me to go over anything, you could. All right. So I'll still leave you to think a bit. All right. What I want you to do, otherwise from here, is go and look up the breathalyzer test. So go in your textbooks as well and see if you could take a look at the breathalyzer test. All right, you're going to see potassium dichromate coming up again with the alcohols. All right, and I would have put some, I'm going to put something on Edmodo there. I think I would have already, if I have not, on alcohol production. All right, so I would like you to take a look at that. So I'm going to just confirm whether or not I would have done it on Edmodo, and if not, I'm going to see if I could put it up one time immediately. All right, so that you could take a look at that. All right, but what I want you to look into is the breathalyzer test and how it works. Yes, the breathalyzer test. Okay, so the breathalyzer test and how it works. Okay. All right, so I would like to thank you guys for making the time to come out to be educated. That is a plus for you guys. Yeah.
I had as much school today as I had regular school.
so you're doing school online as well too?
Yeah.
Okay.
Yeah.
I'm lucky my IT class was moved back from 11 till today to tomorrow.
Okay.
So I didn't go
have English tomorrow.
9 something till now.
Whoa.
Yeah.
Well, we're making the best of the times that we have. All right.
Yeah.
So that's great. But what you think? What you think? What is your thoughts about the whole situation?